Hello, and welcome to MarsPod, the podcast about how AI is changing society and the big picture impact it can have on your daily life. Today's episode is brought to you by MarsCrowd, your one-stop data labeling and collection company, providing real-life data to boost your machine learning models. I'm your host, Mark Wesley, and today's guest is Seth Juarez, who is the leader of the Artificial Intelligence and Machine Learning Advocacy Group at Microsoft. Seth, welcome to the podcast.
Hey, it's good to be here, my friend.
It's good to have you on. I wanted to just kind of start off by asking you to maybe introduce yourself a little bit, maybe kind of what you're doing, where you're at, so that the audience can learn a little bit more before we kind of jump into our conversation.
Absolutely. So I lead the advocacy group for AI and machine learning at Microsoft. Our mission is to empower every developer and data scientist to be successful with AI in the cloud. And we do that by creating content, refining our products, and then growing the communities around them. And so that's basically our job. It's an outward motion as well as an inward motion to not only represent the customers to our product groups, but then to represent the best of our products to our customers. And so that's the role. It's pretty defined as far as I'm concerned, and I have a really good time doing it.
Okay. I mean, it sounds great. It sounds like it's kind of the link between Microsoft and then the audience that might be interacting with that technology.
That is indeed correct.
Okay, great. One question that we like to start off with all of our guests is, what is your AI doomsday scenario? Are you concerned that robots are going to take over the world?
No, I'm concerned that people will rely on faulty data so much that they will create algorithms that will be unfair and unethical, and that people will be denied opportunities based upon those particular pieces of data. That's my doomsday scenario for AI. I don't think we have the current computational models in order to sufficiently approach AGI, artificial general intelligence, but again, that's just my opinion. And I think people that place too much emphasis on machine learning or the AI models and deep learning working like brains, I don't think they're the same thing. Our brains are much more complex. And the reality is that I'm more worried that folks will trust the data that generates the models to create doomsday scenarios. That's what I'm really worried about.
Do you see a lot of that stuff kind of already happening where people are maybe some people are a little bit naive when it comes to technology, where they think, oh, it's technology, so it must be right. But then there's not a lot of thought given to the data that's being put into those models.
I think it's a combination of naivety and just if we close our eyes, maybe it won't be there. The reality is that we are all biased, and there's some that remains unexamined, probably in myself, probably in everybody. And the reality is that the data that we use to create machine learning models is based upon our sometimes unexamined biases. And what happens is, as we shift computation to the right, basically making the data become the functions, what we're doing is, what we're saying is, we're relying on the data from the past to predict the future. And for example, if you're trying to predict whether someone should get a loan, for example, historical data is not good. It's going to be biased. If you're going to predict where people should police, historical data is just not good. And there may be many people that say, well, we remove gender or race or ethnicity or religion. However, just by basic, concepts such as redlining, the address may leak that information to people. And so the reality is that I don't think people are trying to be naive about it. I think what's happening is we're trying to ignore some things that are quite difficult to consume if you're in a privileged group, like I sometimes am, and it's sometimes hard to ignore if you're not in a privileged group. And so that's the thing. I've heard people say things like, "Hey, I don't see color, or I don't see race," and it's really easy to do that when it doesn't affect you. And that's the general problem. If we get a diverse set of people working on these models, then you will see the effects pretty immediately. So I don't think it's naivety. I think it's a combination of, like, everyone's trying to do the best that they can with the knowledge that they have. I probably have some unexamined biases that leak into the work that I do. And it's good to be on guard for that.
So you would kind of say that maybe the best short-term fix would be to just increase the diversity in the team that's making those machine learning models, so that there's greater representation.
That's the first start. Yeah, absolutely. Because then you're going to run into, for example, if you're trying to build AI models for a wide swath of people, right? Then you should have the people that are representative of that wide swath. Let's just say you're making an AI model for mechanics. Then you should probably have a wide swath of people that are mechanics, and generally that would include anyone from both genders, races, ethnicities, religions. And if you have those folks on your team, then it would become apparent to some of those folks on the team to say, hey, this AI model keeps addressing me as a he, even though I'm a she. And that's traditionally because the data from, if you go all the way back from the 1900s to today on all the mechanics, they're probably predominantly male. But I don't know if that's the case. I'd have to look at the data, but I would say that. I've seen some AI models, for example, when you translate from one language from English to another language, like she's a doctor, and then you translate to another language and then translate back, the gender gets replaced by a male because that traditionally, for some reason, there's been a preponderance of doctors. And I don't think that's a mistake. I think, back in the day, that wasn't, quote, woman's work, and I'm using air quotes for those that are listening to the podcast, and that was just abjectly wrong. And so, yeah, I agree with you. Having a diverse set of people in your target audience would certainly help with that.
Yeah, absolutely. And I mean, even something as simple as like the example you gave with mechanics, if you're only taking mechanics for people who, build American cars or something like that, it's going to be limited in its ability to be applied to cars made in other countries.
That's an excellent point. And that isn't as controversial a topic. It's just a different kind of car. And all the measurements might come out, for example, in your regressions in inches, where millimeters is what you do in Japanese cars, for example.
Exactly. Yeah, I think that it's a simple way of understanding something that if you take into every situation on Earth, it becomes a huge, huge problem because it shows up in a lot of different ways.
And that's an interesting point, right? Because maybe it speaks to the effort of maybe narrowing the target of your AI models, which is a really good way of also making it less biased, maybe.
Yeah, if you aren't able to kind of fix something on one end of the spectrum, then you should probably try to address it on the other.
Absolutely.
Yeah. I'd like to kind of look at the areas of interest in AI that you have and kind of what your day looks like at Microsoft.
Awesome. Yeah. So I'm a computer vision guy. I started out when I went to grad school, I did NLP, and I went to grad school when deep learning wasn't really as popular as it is now. As I worked at Microsoft, I transitioned to computer vision because I found that demoing concepts in deep learning was easier across language and ethnicities and people if I used pictures, right? Because a dog is a dog everywhere, right? Language nuance became considerably harder, particularly, right? For like German is very different than French, but then those are still all like Western European languages. When you get into languages like, for example, that are right to left, or languages that are written top down, there's agglutinative languages. I found that it was difficult to do that. So I transitioned over to computer vision. And computer vision is awesome because you can make examples readily available. Like I'm doing a silly project on a show that I do called the AI Show, where I'm sitting there doing like rock, paper, scissors, and it recognizes me doing that, right? And so my day-to-day is interesting, right? Because I can go from talking on a podcast like this to talking to customers, like literally I'm going to talk to some customers right after this, to looking at product challenges that may or may not exist inside of the products that we offer. Like, for example, this morning I had 2 meetings like that where we were presenting several issues with some of our products that we wanted to fix on behalf of our customers, right? And so that's the cool thing, is that my role is basically inbound towards Microsoft. How can we make the developer experience, the data science experience great when using the cloud, to outbound experience, to talking to customers and saying, what is it that you're working on? And how can we make your life easier? And the coolest thing is that one of our biggest motions that we have is this thing called an end-to-end, where we look at an ideal scenario. Like, for example, computer vision. I want to be able to recognize pictures of something on an assembly line and whether or not, the chip is frayed or not. And then if it's bad, then we should alert someone to take that chip off and then send it back through the process. And the cool thing about that is I can make these models and I can pretend I'm a customer. And where the ideal working scenario deviates from product truth, we submit feedback. And that feedback gets looked at across several dimensions. And the product team, we meet with them weekly and talk about this. And we do this across all areas of the company. Microsoft is a very large company, and we have very large organizations looking at different aspects of the machine learning experience. And what we do is we fill in along the seams to show where the cracks are, and we fix them. And our product partners are amazing. They do amazing work, and the level of competence and maturity in the products and how they build them is just second to none. And I really enjoy working with them. At the same time, the customers are doing some impressive work that falls outside of sometimes some of the stuff we even imagined. And so it's cool to bridge those two gaps.
What's an example of like some sort of technology that one of your customers is building that maybe you had to adapt kind of what was going on at Microsoft in order to accommodate that?
That's a really good question. Unfortunately, I'm unable to talk about current customers, but I'll tell you something that we did.
Okay.
that was really fun. So basically, we, for our last conference at Build, and this is a scenario that happens all of the time, we built a time series model. Right, and we were releasing a brand new feature called Managed Endpoints. And the Managed Endpoints feature basically allows you to take a machine learning model and put it into production without having to think about the back-end hardware. And the cool thing is that it's cool for me, maybe not cool for people that are listening, but the reality is that we couldn't use actual stock data. Because imagine, like, let's just say, for example, I used a competitor's stock data, and like I showed that the stock went down. That would look bad. Or what if I used Microsoft's own stock data and it showed that the stock was going down, right? Or other competitors were going, and so it was challenging. And so we had to generate synthetic data, and that was cool for me because I was able to generate things that look like actual stock values for infinity time. So I could make stock for 100 years, 10,000 years until the hard drive broke. And what happened is we started to notice some cracks in the experience between our tooling, Visual Studio Code, and the machine learning backend called Azure Machine Learning. And the coolest thing is we got the PM there and we got some of the devs together before we were going to do this conference. And we said, hey, we're noticing there's some cracks between that. And it's just an organizational thing. Microsoft has a developer division and it has an Azure AI division. And we all sat down. We made some amazing features that enabled customers to deploy their current models that they were building directly to the cloud without really having to do very much thinking. And that to me was really cool. And you're probably thinking, well, how come you didn't see this before? Well, it's because we became customer number one before something even came out, and we were able to deploy this time series models to predict what the future fake stock price was going to be of my model. And surprise, obviously the machine learning model was able to detect the function that I was building before, and so it did it perfectly. So it looked a little fake. But what was surprising was not necessarily the data, but the process that a developer, an ML engineer would take, and seeing that there was gaps between the tooling we provided and the backend we provided, and marrying those up was really, really cool.
What is the size of a team that works on something like that, like from those different departments that you were talking about?
So the people working on this stuff can vary in team size from very small, because it's like a mini startup, to very large. And it depends obviously on the type of thing that is being built. So people work on infrastructure, and that's Azure in general, as well as, for example, people work on features, which may be super small, but still highly important. And we work with all of them. Sometimes if the group is too large, we work at a higher level with their VP, for example. And if the group is super small, we work with the people directly in the group. As far as numbers, I really can't tell, because not because I don't want to divulge it, because I just don't know. Sometimes they say, if I'm working on a thing and I'm like, hey, we're having a struggle with this aspect of the products, they say, well, go talk to Shivani, for example, and then we'll go talk to her, and then it sorts itself out, and they work with the people that they work with. And so in essence, it's almost like we're this weird human API between our products and our customers, and we're like a pseudo PM, like a program manager. We're not PMs per se, because PMs, they have a work back list and they work with the developers, but we might suggest to the PM an alternate way of thinking, and sometimes they suggest alternate ways of thinking for us, which revolutionizes things and how we do them.
I think that the model for predicting stock behavior that you were talking about would be something that a lot of my friends would be interested in getting their hands on. Yeah,
and here's the thing. The funny thing about machine learning is when organizations use it correctly and they use it well, they almost hardly ever talk about it. But when they don't, there was an article, I think it was 2018, CNBC, that said that 70% of European startups, and I'll have to go back and I'll find the link for you, but there was a large number of European startups that had machine learning in the name that didn't actually use it, or AI. And I have, every time I do a talk on machine learning, I have a guy come up and be like, hey, I have a really good idea of how we could use this for stock prices. I'm like, yeah, so has every bank, my friend. And so, yeah, and the model we used was actually really good, but it was on synthetic data. And the reality is that when you're looking at financial data, for example, when you train it, you're training it on perfect data. Right? The stock close price might change the next day, and they make adjustments. Or, for example, if you're doing it based on earnings reports that come out quarterly, sometimes the adjustment on the earnings report come out months after. So it's really hard to do this. But yeah, I have thought of some ideas of doing statistical arbitrage across multiple factors using, for example, LSTMs or RNNs. That it may or may not work, but I haven't tried it because I've already moved on to the next thing. I'm really interested in audio right now because that might be the next thing that I work on.
Okay, what is it? Tell me a little bit about audio. What is it that intrigues you about audio?
So, like I said earlier, I'm a computer vision guy, and it turns out that you can convert audio into similar things like for computer vision. So, for example, if you think of audio as a number happening every, whatever the kilohertz is, it's basically a number that happens. And what you can do is you can take that number and spread it into the multiple frequencies using something like a fast Fourier transformation. And what that does is it gets you the unit waves and how they're added together. And so sound, basically what you're hearing is like a sine wave with multiple amplitudes that are added together. And when you separate those out, for every single number, you can get a spectra of number, right? And those numbers then over time can become like a picture.
Wow.
And then once you have that picture, what you can do is you can use computer vision techniques to see what people are saying. So, for example, you might be able to convert, like you might be able to hear something and then be able to figure out a word from it, for example. Like wake word detection. So, for example, let's just say you want your computer to do something. You might have Siri, for example, or you might have Alexa or whatever, Cortana. The wake word is like, hey, Siri. And usually Siri will wake up when I say that. But maybe I want to find a different wake word, and I just want to make a machine learning model that does something when I say, hey, Siri, or hey, Cortana, right? Or, for example, and right now my Siri just woke up and it doesn't know what I'm saying.
Yeah.
See?
Please repeat it.
That's my Siri. I have the man voice on there. One of the things I do not like is that for some reason, all of the like AIs that are supposed to be like your assistants, for some reason they all have women voices.
Yeah, I changed mine to the man voice as well.
And it's nicer for me because I have like a butler now. It's like my butler that takes requests. And so, yeah, so that's the thing. Like for wake word detection, you might be able to convert sound over time into moving pictures, and then you could use a convolutional neural network to detect, oh, he just said the word, now I need to trigger an action.
That's a really interesting thing. I've not ever thought about seeing like words that are spoken just through like the spectra of data that you were talking about.
And you've played, I don't know, you've probably seen animations of audio, like, you know, when you're looking at all the bars go up and down. That's a similar animation that's happening over time. But imagine freezing those bars and then having them be like a roll of a picture, right? That's basically what it is. And you seeing that, you know, when a bar goes all the way to the top, you're like, oh, somebody's saying something really loud, and it might denote to you something important. Or, for example, when you're editing this podcast, you might see there's no sound, and you know right away visually, if you're editing this, something's wrong there. Or maybe there's a weird silence, I need to go back and cut it. You can imagine scenarios where AI can find scenarios where you don't want that, like the word you might say that a lot. You can train an AI to just cut that out.
Yeah. Then you just want to make sure that it doesn't cut it out if you say the word some, right? Like
exactly. And the cool thing about it is if you do that, and I haven't done this, right? What I'm doing is I'm trying to adapt my computer vision skills into audio. If you do it, it might work, right?
Yeah, it's true. I want to kind of go into some of the other areas of machine learning, like deep learning and quantum computing, and I kind of just get your view on that type of technology and kind of how you interact with it.
Cool. So deep learning is a specialized. So if you think of AI as a huge field, AI has been around forever, and we have this sense of the difference kinds of AI. So, for example, if I tell you I can write a program that will always take you to a draw at tic-tac-toe, you're somehow not as impressed as if I tell you I can write a program that goes on Jeopardy and beats people. Right? Because intuitively in our minds, there is this notion of the space of the right answers. In tic-tac-toe, there's really only 9 answers, and that number goes down as you continue along in the game. If I put a O somewhere, there's really only 8 more places to put an X. And if I put an X here, there's only 7 places where you can put your O, and I can create an algorithm to explore the entire space of every single move that you make and I make for as long as I want to, and I can make it so that you will never beat me. And that's easy. And the reality is that AI has, when it was born, started with this notion of understanding a search space. Like in the set of all things, like if I'm in a room, like what is it that I can do, and how can I make a decision, a set of decisions that will get me to the optimal place. And for example, when you're using Waze and all of a sudden there's a traffic jam and it tells you to go a different way, for some reason people don't think that's AI, but it actually is. It uses an algorithm it may use some kind of algorithm similar to A star, where it has a heuristic function that tells it not only the distance, but also a heuristic on which, path is the best one. And these glorified search algorithms, what I call them, the first for tic-tac-toe is an example of Minimax, and A star is another path finding. These are examples of AI. And when you look at the chess program that beat Kasparov, it was similar. It was able to generate, because chess is a lot more complicated than tic-tac-toe, but you can think of the same kind of situation, and you can think of a tree of decisions that I make, then you make, that I make, but then you can think of, like, for example, there's tons of chess games that have been played, and you can get to a certain state and say, oh, we know what to do at this state, and so you can start clipping the search space. But there came a time where there were certain problems where you could not clip the search space. Like, what's in this picture? All of a sudden, like, or even let's just narrow the question. Is there a dog in this picture? All of a sudden, the search space becomes infinitely large. And so the idea of crafting a function that could search through the space of things, and I'll tell you that I've had situations where people have come to me and say, hey, we want to use an AI to do foo and bar and baz. And I'm just like, hey, you could just do a database lookup for this. Because it can search the space.
Yeah.
But then when we get to situations where, is there a dog in this picture? That's a different problem, because in the set of all pictures of all of humanity and the set of all dogs, all of a sudden there is no way to clip the search space. And so now what we needed to do is we needed to craft functions such that you had to give it the data as examples and the right answer, and it produced a function shape with the right parameterization to solve that problem. And that was machine learning. And machine learning is a subspace of AI, because now it's not just like a, cut and dry, we're going to search the space. Now it's, we'll give you the right answer and you produce a function for us. And deep learning was a subset of machine learning, because in machine learning we have these things called neural networks, but as these things became larger and more expansive with more parameters, this became a subfield of machine learning called deep learning, where again, you have to pick a function shape. You have to learn the best parameters to solve the problem, and then maybe the answer would come out well or not. And so that's how I like to divide up the space, and that's how I understand AI, machine learning, and deep learning.
I see. And then where do you think things are going with quantum computing? I know that that's kind of a buzzword right now where a lot of people are talking about it.
So I feel like I'm a noob at quantum computing. Like there's two ways you can go with quantum computing. You can either learn the physics, or you could learn the computation stuff. And I thought I'm kind of a bottom-up learner, where I kind of want to know every detail of every little thing to understand. And so I went the physics route first, and that was a mistake. I should have gone the computational route. But the way I understand quantum computing, and if there's experts out there that would like to correct me, I'd love to hear your thoughts on that as well, is that the notion of computation is a little bit different. Think of like a qubit, which is a bit, right? And think of you like tossing a rope up and down, and for every qubit you have a rope, right? And the thing about it is that you could be in any number of states at the same time until you look at it, right? And so imagine being able to move this rope a little bit higher and this rope a little bit bigger and whatever, and a number of qubits that you have, you're able to produce these waves inside of the qubits that point to a certain direction. And what you do is you're basically from behind a curtain, like manipulating these qubits, and then when you look, you're able to get an answer. So for example, you're able to represent a huge amount of different states until you look at it. And the leap that I still need to make is, how is it useful to be able to have things in a weird state and then move them around such that you get an answer? And whenever you do quantum operations, if you're working with a qubit, you send in a vector to change things, a matrix to change things up, 2 by 2. When you have 2, then it gets bigger, right? And then 8, and so on. And so you're basically sending this matrix in, moving the configurations of the state, and then until you get an answer. And here's an interesting way to think about it. And I did a video on this a little while back with someone at one of our conferences. Think of a situation where you have like 10 people lined up, right? And someone's at the gate, right? And they either let everyone in or half of the people in. If you're doing this in regular, computing, you'd have to like ask every one of them, and which is order n. In quantum computing, if I remember right, you can do it in a single lookup. And so that's the beauty of it. You're able to do more things. In my particular opinion, is that our brains work at a quantum level, and that we're able to do computation in our brains at a molecular level, and we're able to envision a lot of things at the same time and then snap to a decision. And my current theory, and again, I'm no PhD. I have a master's in computer science and machine learning. I'm not like, I know some quantum. I've read the books. I know the physics, and I know how the operations work. But my sense is that if we get to an intelligence, it would probably be under quantum computational models. Having said that, there's only certain things that you can solve with quantum computers. If you think of a quantum computer as a GPU, right, there's only certain things GPUs do well, which is matrix computation at a large scale. And that's why they're so good at machine learning. Because if I were to tell you, you and all your listeners a secret, machine learning is basically, linear algebra turtles all the way down. And that's why GPUs are awesome. Quantum computers are really not computers, but they're like GPUs that you have a regular computer, you send it something to process, you get it back, right? And so we're still far away from that. My sense is that one of the cool things is that optimization algorithms might be better in quantum computing, but I still haven't figured out how or why.
Yeah, we had a guest early on in the podcast. Her name is Twain Leo, and she was talking about how quantum computing may be the answer to bias in machine learning models, because with the binary method that exists, a lot of times you're put into situations where you have to determine if something's a 0 or a 1, and a lot of times that creates like a false dichotomy. But because of quantum computing, multiple states could be true at the same time. It could do something to alleviate some of the issues that come from a binary model and kind of allow for nuance.
Maybe. They're probably more an expert than I am, but you can in machine learning come up with something that's not 0 or 1. You can come up with a vector of probabilities that tells you the probabilities of things. But the reality is that if the data is biased, you actually have to sacrifice accuracy to de-bias models. And by accuracy, and here's another secret. I don't know if it's a secret, but something that people don't realize. When someone says a model is 99.9% accurate, they mean 99.9% accurate on the held out test data, not on all things that this model may ever see in its entire life. And that's genuinely the problem. Like, we build 99% accurate models, on your test data. And if you're solving for bias on test data and training data, you might not even have all the right data to do the right thing. And I probably would suspect that the data is also biased. And so it's almost like saying we can make faster cars and fix the dirty gas problem. Maybe we should fix the dirty gas problem to make more efficient cars. I don't know. And so that is my personal opinion, is that we need to seriously look at the biases that we have in our data. And there's a number of ways to do that. This is not an unknown problem. At Microsoft, we're working on two things: something called FairLearn that lets you look at assess and mitigate fairness issues in models, and then we have something called erroranalysis.ai that lets you look at why models are predicting the way they do when they make errors in the test data. And it might be gender based. It might be socioeconomic based. It might be a number of things, but at least you can look at this. We also have ways of mitigating unfairness by sacrificing accuracy, which is really cool, because you're sacrificing accuracy again on an inflated whatever test data you have, but you're fixing bias issues. And so we have a number of ways of correcting that. And at Microsoft, we have some very strict responsible AI principles that we need to be called out if we're not following them.
Absolutely. There was one other guest that we had on the podcast, and he talked about the importance of having traceable machine learning models, where it's like if there's a breakdown in something, you need to be able to trace where the breakdown happened. And we kind of used the example of autonomous driving. Like, maybe in the machine learning model, the car got in an accident, but it actually wasn't a mistake based on the way that it was trained. Right. And then it ran into a scenario where it did what it was programmed to do, and it just had the wrong output, or just it did what it was supposed to do, but it's not what you would have wanted it to do when you were programming it. And so being able to trace where the breakdown happened was something that he says is crucial for machine learning. Yeah,
absolutely. And especially when with complex AI systems such as autonomous driving, which have, I don't know how many models running at the same time, hundreds or thousands of models at the same time. I don't know if it's that many. I'll have to look into it, because that's interesting. But now you have multiple models working with huge sets of data, and it may be hard to pinpoint. But you can see the output of every one of these models. And if you think of an AI model as just a function that we wrote with data, it's easier to start thinking about the engineering aspects of these things. Like, you can unit test functions. You can also unit test models, because it's just a function you made with data. And for me, machine learning is the process of converting data into functionality, converting the nouns into the verbs. And that's important. And you know that if you convert a noun into a verb, sometimes you lose fidelity. Or sometimes you gain fidelity that you did not want.
Exactly. And also, like, going back to what you said about, you're kind of in a very safe environment to test these models, and it's not, really giving you a clear picture of what the real world would look like, because we have no idea, all of the different types of ways somebody might try to interact with that technology and the way that it could be tested in a way that you couldn't plan for.
Yeah. And for example, if you think about, like, for example, currently we have vaccines for COVID, the way they test those things is pretty principled, because they know that in the lab it works. But then there's some very specific regulations, and obviously they relaxed some of them for COVID, but a vaccine might take 10 years. Because they got to release it to a small subset of people, and then they look at it and did it work? And then they release it to a larger set of people, and then if something goes wrong, they study what went wrong. Because in biological processes, the reality is that we don't know how these things react for every person, especially for biology, right? And so I would say the same kind of care needs to be taken when doing machine learning models, especially if there's harms that could happen because of it. Whether harms of allocation, right, or of allocation of service, or harms of fairness, and equity.
Yeah. That's the thing, is like, it's true, like what you said, and I think the sad reality for a lot of people is that they're not motivated by trying to create the most fair model or something like that. They're motivated by how fast can we get this to market and how much money can we make based off of the technology. And so it's hopefully there's enough people out there that are more focused on being able to create a fairer model.
But I will say, if you think about it, it's probably in the long run better for an organization to do that, because think of it, if your model all of a sudden discriminates against large swaths of people, that large swath of people also have money and they can also pay for your service. And then think about, like, nowadays, especially if your model is biased and it gets put out in the media, or that's a challenge. It could cause, and everyone might be very well-meaning. I'm not saying people are doing this maliciously. I don't want anyone to think like, hey, people are putting out malicious models. Maybe few people are, but I think the majority of people aren't. I think the reality is that you need to consider these issues, because if you do, you will live longer than the ones who don't. As an organization in a capitalist system.
Exactly. It's just more sustainable if you're able to do something that can withstand all of the tests that it will kind of experience through its lifetime, right? I have a background in like search engine optimization, and the first company that I worked at that kind of taught me the basics just told us, like, don't try to do shortcuts, because Google is going to punish that eventually. They may not punish it now, but they're going to punish it eventually. And then the things that you're doing for your clients, they're going to end up working against you. So do things the right way, even if it takes longer, and just explain that to people that, this is a long-term approach. And I think it's kind of similar to what you just said.
Yeah, absolutely. And also just go in there understanding that even if you've done your best, there's still going to be an issue with the model. Just like, like regular code has issues. And you might, for example, like, let's just say your database got hacked and all your hashed passwords got released. The best thing to do is be like, hey, everybody, we had to reset everybody's passwords. Please log in again. This happened, and we're terribly sorry. We're going to figure out what happened, and we want to do the best by you. So we told you early, and we tell you often if there's an issue.
Yeah.
And that also breeds trust, because everyone understands that we live in an environment now where sometimes things just don't work. Yeah. And that's okay. But if you tell me early and you tell me often, then I can be an adult and make decisions about the services and products that I patronize.
Absolutely. I want to kind of go into another area that we generally, have a discussion with all of our guests, and that's what is your ideal vision for AI, but also like what is also a realistic vision for AI? Like kind of maybe those two are one and the same, but maybe you see there's one area where it's ideal, but then you're maybe a little bit less optimistic about it. And so you have an idea of where you actually think it's headed.
So for me, there is a number of tasks, and you know this, Mark, and your listeners probably know this as well, where you do not use a lot of cognitive function, but you can still perform the task. For example, Christmas card season comes around. That's if you celebrate Christmas or if you celebrate Hanukkah or whatever, you send your holiday greetings. Notice that task is very brainless. You basically put something in an envelope, you put the address on and you put the thing and then you don't think about it. Or wrapping presents, for example. Like I have 4 kids, and so we try to make it so they have, presents to open. It's kind of a brainless task. There's other things like that you do in a computer that, for example, you have to click here and then you have to click here and then you hit return and you click here. Those types of lower level cognitive tasks, I think, are perfect for AI. And in a real world like it, my hope is that those lower level cognitive functions AI can take over so that humanity can level up. And what do I mean by that? Like the Industrial Revolution was awesome because it allowed us to move from human-powered muscle to machine-powered, steam, for example. And all of a sudden, humanity could do more. And that's I think would be awesome for AI, that we would be able to up-level humanity by taking the lower-level cognitive functions and making those tasks easily done by a computer, therefore up-leveling. Now, there may be those out there that are concerned, well, what if it takes away my job? And that's a concern that's happened since the beginning of time. In fact, you remember when you hear the term Luddite, if you look up what was actually happening, it was a bunch of people that made cloth that were worried about the loom. And they found a job. Like when Henry Ford put out the car, how do you think the horseshoe maker felt? We adapt, and humanity can adapt. And if we adapt to up-leveling, the stuff that we work on to higher cognitive function, we could solve a bunch of problems. Bunch of problems. Like, for example, hunger, right? Or global warming, or things like that, so that we can up-level humanity. And so, there is a concern that some of these lower-level cognitive functional jobs could be taken, but then that's an opportunity for people to be up level. And that, I might be saying that from a privileged position, and I'm happy to take people's responses to that. But that's where I see AI going. The lower level cognitive functions can be taken over by computing, for example.
Absolutely. I mean, it is tough because it's like if you are the victim of some sort of displacement, like job displacement or something like that, it might be easier said than done to just be like, well, I can move on to something else. But technology is something that improves over the course of time throughout history. And so these types of things end up happening. I remember when I was, kind of getting my degree, like one of my professors just said, the most important thing is to be able to remain flexible in what you do, because you don't know where the need is going to be at a particular time. And so I have thought about that, and I always try to supplement something that I'm doing with something new that I can learn. But because I don't know. I mean, maybe some of the functions of my job are going to end up being taken over. It's like an automated function. So yeah, it's an interesting thought. I wanted to also ask you one of our final questions, which is, what is one misconception that people have about AI that you'd like to set the record straight on?
Yeah, so the biggest one, I think, is whenever someone is confronted with a complex problem, the answer invariably goes to, well, we should use AI. And that's like saying we should use a sledgehammer for everything, right? I want to kill a fly, let me use a sledgehammer. You could certainly kill a fly with a sledgehammer, but you might break other things. AI doesn't figure out things on its own. You have to, as a data scientist, give it a shape of a thing, like the function. You know how I said it's converting data into functionality? That function shape you have to pick initially as a data scientist, and you have to run your data through it to see if it actually can do the inference that you want it to do. And there's only really certain classes of problems that it can solve. It doesn't solve everything, but it kind of looks like it does, but it really doesn't. So for example, how much or how many, it can do that. Which class does this belong to? Is this weird? Anomalies? Can I group stuff together? And what happens is when you start to put these things together, it seems like it's smart. I'll give you an example. Collaborative filtering is something that you may have heard of, but for sure and if you haven't, for sure you have experienced it. Collaborative filtering is the type of machine learning where the website suggests that you might like this product or service. How does it do that? Well, easy. It creates groups. If you have a product in group A, then maybe you'll like another product in group A. See, that's really easy. That's just like clustering. Well, what if you go to the next level? What if you use two clusters? You cluster people and you cluster products. Well, if you and I, if are similar based upon some arbitrary measure that the computer figured out, and you put product A in your basket and I don't have product A in my basket, the computer will say, maybe you should put product A in your basket. I'm like, well, yes, that's true. My friend Mark literally just put that in there himself. How did you know? Well, that's collaborative filtering, right? And that's something that you're experiencing, but you have to, that's a very specific question that you're asking. You can't say, hey, AI, do this for me. And you're like, well, I tell that to Siri all the time. No, you don't. You're telling Siri to translate language, right? And that language, it brackets into commands, right? And those commands, it then executes. It's not like, for example, hey, Siri, call so-and-so and such. It knows the word call, and then it knows how to search so it's very specific. It's basically a language problem converted into a programming problem. And so that's the misconception, that AI can really do anything. It's kind of like the same quantum thing. Like the quantum can do anything. Yeah, it can do a lot of amazing things. But I think of it more as a GPU, that you attach to regular computers.
Yeah, absolutely. It's some people, I think that part of it is just the general excitement or optimism about where the technology is headed, and maybe sometimes it's easy to get carried away with like, oh, all of these new possibilities.
It's definitely easy. In terms of AI, we've had 2 or 3 AI winters because of this precise problem. When expert systems stopped being good, then we had the funding dried up. Prologue wasn't the answer. It turns out you can't write the rules for everything and have it figure out life. And then when machine learning started to become not as cool, and then deep learning came up again, we're starting to enter the plateau, of deep learning. And if we overpromise, we might have another AI winter.
Yeah. Absolutely. Well, I just want to say thank you again for being on the podcast. It's been a pleasure having you on. I wanted to ask you if there's any maybe way that people can get in touch with you or kind of interact with some of the resources that you've provided. Where could they find that?
Yeah, absolutely. You can reach out on Twitter. It's just at Seth Juarez, Juarez, or SethJuarez.com is my website. Or you can just email me, You can find me easily on it's just my first name dot last name at Microsoft.com. If you have any questions, and I'm happy to direct you to the right people. Sometimes I'm a little slow on email. Apologies for that up front. I have a problem with volume sometimes, but I'm happy to help out wherever I can in pragmatic uses of machine learning and AI.
Absolutely. Well, thank you, Seth. I really appreciate your time.
My pleasure.
All right. That concludes today's episode. We want to thank you for listening all the way to the end. This episode was brought to you by MarsCrowd, your one-stop data labeling and collection service provider. For more info, feel free to click the website link in the description. We look forward to you tuning in for our next episode on how AI is changing society.